My dear BYJU'S achievers, welcome to another session on light. And you know what? Whenever we go for light, we just need to say, let there be light. That's what we do, right? So today we are going to discuss about spherical mirrors, image formation by spherical mirrors. And yes, I can see a lot of familiar faces. I can see Shazadi, Rohit, Bobby Singh, Madhav, Syed. Hello, good evening. So before we move on, just let me know, am I clearly audible and visible? Which I'm thinking any one of you is typing right now while I'm asking you this. Good evening, hey Harthi, Arlene, hello, Rohit, Gaurav, hi, Jagdeshwar, hello, hi. Alright, yes, new student, huh? Welcome Gauransh, Rita, Bobby. So, am I clearly audible? First of all, guys, just let me know this with a thumbs up, with a smiley, whatever. Hey, Abhi. Perfectly clear and audible. Alright, Syed has given me a heads up. Nice. Bilkul hai. Badhiya. Good evening. Hello, Firdaus. Alright. So, duration, Madhav, would be around 45 minutes. We'll try to keep it short because this is an important concept if you see, right? Spherical mirrors. So in light, we have dealt with plane mirrors, correct? Now we are moving towards spherical mirrors, the curved mirrors we call them, right? And we'll also do a lot of activities today. I have brought mirrors with me. I have a candle. I have a matchbox also. So we'll do some activities in this session. We'll do poll questions. We'll do some interactive questions, and that's why this session will make it awesome. And you know what? You guys will make it awesome. Fine. All right. I'm not audible to Kritiman. Is there anyone who is facing this problem? Which I don't think. But Kritiman, just check if the earphones and everything is working fine. Oh, you're welcome, Gaurav. All right, guys. Let's start. I'm good, Shruti. Thank you for asking. And I hope you're also well. All right, nice. Okay, so next, you remember this thing, right? Early start to class 9th in boards 2023. So 45 days plan, and we are going to stick to it. That's what we have discussed. This is the promise which you and I have made together. Fine. All right. Then the scholarship test, every Sunday it happens. Please don't. It's okay, Shashank. It's okay. Take a break with studies. With study, right? Take a break from entertainment with studies. All right. So this BYJU'S scholarship test is happening every Sunday. Register, take it, and you know what? I would say, see how it goes with everyone in the country, right? So that's a good thing. It's a good opportunity. Nice. Pranam, Dipesh. All right. So let's move forward. Observe closely. See, we have seen plane mirrors. We all have seen plane mirrors. It looks fine. It looks good. And we have been using them in dressing mirrors and everything. But they are not the only type of mirrors we have seen. We have seen others also. Do you remember where? Can someone tell me where you have seen other mirrors? Or do you want some help? Okay, I'll give you a hint. You have seen these kind of mirrors. And you know what? It's not just a picture. Right? This is telling you that yes, you have seen these mirrors. Where? In car, in automobiles, yes. Spherical mirrors in saloons, yes, okay. Car side, convex, makeup, in bike, correct. Solar pressure cookers, oh nice. Dentist mirrors. Alright, means you have seen them, right? And these two were actually shots of parking space. In parking also you have seen these kind of mirrors. You know, this is what happens there. Right? Ha, Shashank, that's also true. Oh, nice. It covers more area. Huh? Good. Alright, so that's why. These are all, we call this category as one. What? Periscope. Periscope mein, Jagdeshwar, there was plane mirror, no. Plane mirrors at 45-degree angles. Nice. All right, all right. So spherical mirrors, it's a category. We call them curved mirrors, or more technically spherical mirrors. Why spherical? Why spherical? Because we assume that at some point in their life, they were part of a sphere, right? They were part of a sphere. And you take that sphere and you cut that sphere, right? If you take this sphere and you cut it from here and from that side, right? This is what we say. If you take this sphere and you cut it from here and here, you will get two sections, right? One this and one this, correct? True? Yeah, because they are a part of sphere. Correct, correct. Beam. Tavishi, yes, you're right. They were a part of sphere. Nice. Shamna. Nice, nice. Hollow sphere, obviously, like a glass sphere, no? And then, once you have cut them, glass pieces which are a part of a sphere, then what you do? You take them and you polish them. You polish them so that you can make the other side reflective, right? I'm good, Amrita, right? Yes. So what I've done is, these were two sections, right? These were two sections. For this one, I have polished the inner part. Now, which means this part became reflective. I have polished this part became reflective. And in the second case, in the first case, silver coating is inwards. And it became a convex mirror, right? It became a convex mirror, correct? Nice, nice. Silver, aluminium, right? You are right, you are right. So it became a convex mirror, means the outward part is reflective. And in the second case, what happened is you silvered this portion, right? This outward bulging portion means this inward curved portion becomes reflective. So it became silver coating is outwards, means it became a concave mirror, right? By what should the mirror be polished? We use silver coating, mercury coating, these things are there, and then you bring something else to hold that coating, right? There is a covering. It's not like just you coat something and you leave it. You give a support to it, right? Yes, yes. Correct. All right. So is this thing clear? First of all, you know what? The first problem or the first confusion that comes is, sir, how to remember? Which one is convex, which one is concave? And I'm sure a lot of us have developed our own methods to remember it, right? See, for me, if I tell you how I used to remember is convex. Vex means something bulging outwards, right? It's a vex. So convex means, oh, the outward part is reflective. Concave. Cave means something deep, right? So deep is this curved inward parts. This is for me a cave. So it became a concave mirror, right? So Amit, these things will come. Applications we'll talk about in this session. Madhav, it was ancient, our ancestors used to make that. I'm still not sure how they used to do that. Glasses, because nowadays we manufacture glasses. Yes, correct, Parvati. Actually, you also remember the same way. Nice, Shevnant. Sorry, nice, Revant. With a spoon. Yes, Chetna, that also works. So, I'm saying, develop your methods the way you want to remember it. But what is important? That you remember it, right? Take whatever help you want, take whatever thing you want, but remember this, right? Concave and convex. Confusion should not be there. That is the intent. Nice. Oh, I can see a lot of you remember the same way. Huh? Nice, nice. I'm not alone then. Huh? Good, good. Very good. Nice. So, with this, now that we have started, our story started with both of them were part of a sphere. Now, every sphere would have a center, correct? They would have a center. Cave means, concave means cave, correct? So, every sphere would have a center, alright? Means that center of which the mirror was a part of. That center is center of sphere, and the distance between the outside surface and the center is what we are calling as radius of that sphere of which mirror was a part of, right? Correct? Oh, nice, Chaya. True? Alright. So this means that, understanding it like this makes this terminology easy for us. How? This was the sphere and this line. The line joining the center and the center of this mirror which came, right? If this was a mirror, there is a center of this mirror. If this was a mirror, there is a center of this mirror. This center is what we call as pole. So pole and center of that sphere, there is a line. If you just draw, this we call as the principal axis, correct? Yeah, Muskan, I'm repeating it. So what I'm saying is that sphere had a center, right? So the center of the mirror, if this mirror was a part of a sphere, the center of this mirror is what we call as pole. Pole and that center of the sphere of which this mirror was a part of, if you join a line, that line is what we call as principal axis. Okay? Thank you, Asta. Alright, correct? Nice. So if principal axis is clear to you, next thing we just discussed was pole, right? The pole is what? The center, the geometrical center of your mirror. So fine, okay, nice, nice. Alright, you guys know a little forward also, very good. Next is C. What is C? Center of curvature. What is center of curvature? It is the center of the mirror or the center of the sphere of which mirror was a part of. Correct? Yes, Amber. It's a imaginary line passing through center and pole. That is what principal axis is. Correct. Nice. Alright. So you got center of curvature also. Next, radius of curvature becomes then. See, you have center. You have the center of the mirror also. This length between center of curvature and pole, it will be what? Radius of curvature only, no? Right? See, I would say, Jagadeshwar, principal axis is the complete line. And this segment on principal axis between center of curvature and pole, this length is what we call as radius of curvature. Okay? Beam, you can, but you know what? I would say, don't use it in very technical terms. Casually we can say, see, aperture also is, aperture is normally the small opening, right, that we call as aperture. But I would say avoid it. Center of mirror is what I would say it's better, right? Oh, hi, your name is Utkarsha, okay. So aperture is, don't worry guys, I'll talk about aperture, not now. Aperture in very general terms, I would say your eye has a small opening, no? The what we call as pupil. So aperture is a small opening. In camera we have aperture, in your eye we have aperture. So right now I would say don't focus on aperture. Fine, nice. Principal axis is just like a diameter. You can think like that. Alright, fine. So radius of curvature is also good. Now that we have understood this much, let's understand using an activity. Let's go through a simulation and see whatever we have learned, does it really work like that? Right? Come on. Alright, alright. Madhav will talk about that in the section of the eye. By the way, it's convex. Alright, so let's go and see what we have. Alright. Ready? Ready for the simulation? Okay, okay. So this is an interactive question, right? So let's see. This is drag and drop the given mirrors in the dotted box and observe if the piece of paper catches fire. Oh, okay, okay. Drag and drop the option on the highlighted area. So let's see, if I drop a plane mirror, what happens? So these 6 lasers were fired, but the paper did not burn. Right? Correct? Oh, nice. You people are answering concave and convex. Alright, see, concave I think is winning, but still, let's try convex also. So what happens? Oh, when the lasers were fired, they got diverged after getting reflected from the convex mirror, right? It won't catch fire in plane, that's true, Afshan. Let's see concave. Convex mirror is a diverging mirror. Let's see. Let's see with concave now. Oh yes, I can drag it like this. Oh yes. In this case, all the rays are getting concentrated on the paper and you can see it starts burning, right? So concave mirror is what we call as a converging mirror. And looking at this, you can understand why it is called a converging mirror. When all the parallel rays fall on the concave mirror, after reflection, they converge at one point. That's why we call it a converging mirror, right? What is diverging? Good question, Asta. Diverging is after reflection, The light rays diverge. They fall on a surface and then they diverge, right? They fall like this, and let's say if this is the mirror surface, they fall like this and then they diverge, right? They spread out. That is what we call as diverging. Yeah, Shashank, that's true. Laws of reflection, it's there and it will always follow. And this we have discussed. Wherever there is reflection, laws of reflection will hold true, right? Okay. So based on this, we can have a question. Which of the following mirrors can be used in a solar cooker? And I think someone gave this answer in the starting itself. Yes, correct, Madhav. Nice. Yes, Afshan, that's also correct. Hello, Varsh. Nice. So people are saying concave mirror, and that is the correct solution. See, in solar cooker, always think what is your requirement first. My requirement is that the sun's rays, which are coming from infinite, very, very far away from me, those rays fall on a mirror and then they should get focused at a point, because you want to cook food, you want more energy, you want heat, right? So you want to focus all this energy at one point so that the food can be cooked faster. You don't have infinity for the food to cook. No, you just keep it in sun waiting for it to get cooked. No, you want to concentrate all the sun rays on it. Who will concentrate? A converging mirror. And that's why the answer is converging mirror. It's okay, Shank, not a problem. Yes, it's there. Right? So, Riya, the reason they are using concave here is because you want to cook food. You want to converge all the sun's rays at one point. And what is the converging mirror? It's the concave mirror. That's why the answer is concave mirror. Right? So, with this question, we have understood this. Let's get back to the session. Alright. Yes? Fine. Nice. Correct, Madhav. Okay. So let's move forward then. Let's talk about first principal focus. Varsh, I think this might be a net issue. Just see if the video quality is it selected at least 720. I would say selected. Right? Alright. So it's clear. I think somewhere at some places there might be a small net issue, and that's why the video is not clear for you. Alright guys, come on. Principal focus. What is principal focus? The point where light rays converge after reflection. Acha, there is one question which I have been meaning to ask you. Is there any difference between focus and principal focus? And this question I won't answer today, but I'm just asking you. Do you know that? And if you know, I would want its answers in the comment section, because it's Noah. Amrita says yes. No. There is no difference. Okay. Alright. See, you know what? There is one difference, and I would say once this session is finished, look for it and answer it in the comments, right? And I'm definitely going to take this in the next session. I'm telling you, this is a good question, and usually I get mixed response whenever I ask this in any class. Nice, but don't tell in the chat. Huh? Alright. I want your answers in the comment section. Alright. So principal focus is point where light rays converge after reflection. The light rays which are parallel to principal axis, they converge after reflection at principal focus. Fine. Okay. Nice. I think Jagdeshwar has the answer. Point from where light rays appear to diverge after reflection. So what happens here is, see, and guys notice here, because I have seen a lot of students getting confused over here. Parallel rays come, they strike the concave mirror and get diverged. So one thing is pretty clear. See, on this side of the mirror, they will never meet, right? They cannot meet. Why? Because after falling on the mirror, they are just spreading. So there is no way they can meet. But you know what? When you trace them behind the mirror, if you take a look from here, your eye and brain together have a tendency to think light is coming from the straight line. So they will think, oh, it is coming from behind the mirror from that point called focus. So that's the trick. All right, sir. No, no. Yes. Convex mirror known as diverging mirror. That's true. Correct, Ria. You're right. Nice. So, convex mirror is also fine. Principal focus for both is clear now. For concave also, where the rays actually meet. And in convex, what is? Point where light rays appear to diverge after reflection, right? The point behind the mirror, inside the mirror, okay? Correct, Astha. That's true. Nice. Now, you know what? What is this? Can someone see, and do you know the tale behind this picture? Someone, do you know? There is a legend, I would say there is a little myth also, but you know, it's a very good legend, and it's a very famous legend about Archimedes, not Ariston. Nice, Prahand. Yeah, Archimedes, right? So this was the famous battle of Syracuse. When Syracuse city was attacked from Greek soldiers, what Archimedes, and Archimedes was like the brain of that city. So King Heron, he came to Archimedes saying, please save the city. You are so smart, do something. He built inventions which the world had never seen before. So what he did, there were ships coming from the sea, and there was nice sunny day. So he built such huge concave mirrors that he focused the sun's rays, and those wooden ships, they got burnt in the sea. Yes, right? And Archimedes is famous, at least in our student life. We remember Archimedes for what? Not exactly this, but there is something else. What do we remember Archimedes for? Does someone know the term? At least the... Yes? It has more aperture. It's basically bigger. It has more diameter, right? Jagdishwar, correct. Nice, Tavishi. Archimedes principle. Flotation, Archimedes principle. So it means Archimedes sir will come again in our life, okay? In flotation. That's perfect, right? Fine. So whenever we learn about flotation, we have to learn Archimedes principle. That's true? Yes? Buoyancy. Correct. Right? So that's why. And there was, and you know what? There was one more invention which he did, catapult. Do you know catapult? It's not that catapult, the gulail which we do. That's not exactly catapult. Catapult is, how many have seen old movies where you put a stone and then you release and the stone goes like, tush, right? And the stone goes, ooh, boom. So this thing happens in catapult. So he was also the inventor of catapult, okay? War equipment. Yes, Jagdishwar. All right. So that's how he used concave mirrors to burn ships, to concentrate the sun's rays and burn ships. I don't know if it's real or not, but looks cool. It sounds cool, right? So yeah, that's why I'm just telling you a good story, which is famous, right? In Pirates of Caribbean. In Bahubali. Nice. Parvati, it is possible, but one problem is that the intensity you want to burn ships, it's still debatable, right? There are nice videos on YouTube where people have tested this, right? They have tried to test this myth, and there were mixed opinions which came out. So I'm saying it's still debatable, but it's a good legend, okay? Yes. All right. Virtual image, Jagdeshwar, I'll come to this, don't worry. Virtual image is what? The image which is formed inside the mirror, right? Which is inside the mirror, cannot be formed on screen, where light rays don't actually meet. That is all the virtual mirror, right? Huge concave mirror, Shanmugam. You know what they did? They added multiple concave mirrors. And that's how they got a huge converging mirror. You might have seen images of Hubble telescope. They have that huge mirrors, no? Hexagonal mirrors added together. If you just see the pictures afterwards, huh? Nice. Correct. All right. So let's see. Special rays for ray diagrams. What are the special rays? So these things are important, guys. See, this is important for ray diagram making. So till now we have understood. No scientific enthusiast. It doesn't need, because in between it's vacuum, no, between sun and earth. But still you see light. Correct? right? So this thing, the special rays concept is very important, because whenever you try to make ray diagrams for any mirror, for plane, for concave, for convex, you need to know some basic rays so that you can choose how to make the ray diagram for any object and image formation, right? So let's see. The first important ray is, it's quite obvious. First important ray is a ray parallel to principal axis, and it's a concave mirror, means after reflection what will happen? This ray is bound to pass through focus of the mirror, correct? Taisha, that table, I will also show that table. I'll also do an activity with that table, but that table gives you idea of where the image will be, right? So you can learn it, but you know what? This way, I would say you will always remember it. That's important, Nana? Yes, Astha, definitely. Alright, so this first ray is fine. Second one, what do you think this ray will do? So this ray is passing through focus and falling on the mirror. Now what should happen with this? Can someone tell me? This ray, what should happen with this ray? The ray which is going or passing through focus and falling on the concave mirror. Right? Oh, beam, nice. It will become parallel to principal axis, right? It will become parallel to principal axis because it's just reverse if you see, right? So this ray will become parallel to principal axis, correct? Nice, very good, very good. Surat, there is a, you can submit in the comments and below the video, no, there are comment section. You can submit your homework there. Nice, fine. Oh, this one is good. This one is good. See, this ray, if you watch, this ray is coming or passing through center of curvature and falling on the mirror. What will happen with this ray? I can see some of you had already answered all the 4 combinations, but still, what do you think? Nice, Mansi. Correct, it will trace the same path. Reverse, Tavishi, Kalpesh, right. Chota Bhim has already answered this. Gauzia, facts on fire, return back. Why does it return back? That's another question. That's another question. Why does it return back? Can someone tell me why does it return back? In very quick words. Why? Why does any ray trace the same path after reflection? Normal, correct, because it is falling at 90 degrees to the surface, right? It is passing through C, center of curvature, and the mirror. Whenever you join, at wherever point you join, it is actually falling at normal to the surface. True, right? Nice. Angle of incidence is 0 degrees. Very good. Oh, nice. You guys are so brilliant, huh? Nice. Very good. So next one is this one. So this one is quite easy. See, this one is here principal axis is actually acting as a normal. So here again, angle of incidence is equal to angle of reflection. Same thing, right? So Parvati, it goes back from center of curvature is because, see, in a sphere, whenever you join the surface of sphere from the center of curvature, it will be 90 degrees. The angle would be 90 degrees, okay? That's important. Nice, alright. I will call you Puvi. So Puvi, we'll do Menti, but once we are done with concept, because Menti has only questions now. First we need to learn concepts, then go for questions. That's why, right? Nice. Law of reflection are followed here. Alright. So this is a poll question. So I won't give you Menti right now, but I'll give you a poll question. Tell me, if an incident ray goes parallel to the principal axis, then the reflected ray will pass through the dashed line. So I'll give you just 4 options, A, B, C and D. And I'll give you 30 seconds, okay? Right? So, Mitraj, next class I'll tell you. Before the ending, I'll tell you about the next class, alright? So, I'll give you 30 seconds, your time starts now. Tell me, red, green, blue or yellow? Which one is it? Simple question only, no? Right? Okay, let's see. How much percentage of students answer it correct? Huh? Let's see. So everybody is saying C. Huh? Alright. Nice. C has 88% votes. Nice. It was an easy question. I am pretty sure this was an easy question. And yes, you guys did it well. Very good. So answer is option C. Now, let's go for what kind of image formation happens, right? So when the object is at infinity, like sun is where? It's far, far away from us. So we say it's at infinite, right? It's at infinite distance, right? Okay. Yeah, this was obvious to be green one. So rays are coming parallel to principal axis. They fall on the mirror and then they converge at a point which is focus. So what do you think? This image, the final image which you are getting here of the sun, this image it is on focus. It is highly diminished because you are getting a point size image, no? And it is real and inverted, okay? Right? True? It meets at focus. So, Shashank, the object is at infinite, means rays are coming from infinite. They are falling on the mirror and converging at a single point. That point is focus, and that's where the image is coming, right? Nice. Real and inverted and highly diminished. That's important. Correct? Nice. All right. When the object is beyond C, then what happens? What is beyond C? Infinite is very far. Now you are coming closer to mirror. Slowly you are coming to closer, right? So this is focus, center of curvature. This is your mirror. It's just beyond C. It's right. It's if you just move forward to C, there is the object. Fine. So see, you know these three ways or these three common rays or special rays, I would say. So a lot of times I have seen students get confused, sir, which ray to take, or if I take any special ray, will I still get the same answer? Okay, let's see. So that's why, right? That's why we are doing this. Thank you, Yaneshwar. So this activity I'm doing because of the confusion which comes in you afterwards. So let's take two of the special rays first, right? Let's take these two special rays and see what is the image we are getting. Object is beyond C. So one ray is parallel to principal axis. Second one is passing through focus, right? So I'm getting an image over here. All right, fine. This is most confusing. Okay. So do you believe me? That image will be here, right? Wherever these final rays are meeting, that is where the image will be. And if you see, here at this point the rays are actually meeting, right? You can believe on this, right? Rays are actually meeting, and when they actually meet, it is a real image, right? You can see this is my object is like this and image is like this. Image is inverted also, correct? So image is real, it is inverted, and if you have a look, object is bigger than the image, means image is diminished also. Fine, right? So oblique, now whenever we say oblique means this is normal and this is oblique. Fine. Whenever it falls like this, it is oblique, what we call it. Atashi. That's a good question. This is why we say this is a little hypothetical case, but it is inverted. I mean, it's meant to be inverted, right? Yeah, Parvati, I'll tell you this trick. Diminished means smaller, facts on fire, okay? So, when I took these two special rays, right? When I took these two special rays, I found that image is coming over here. Now, let me take any other two. Let me take these two. The first one and the second one, right? So, this thing when we do, what do you see? Look. You have taken a ray passing through center of curvature and another ray you have taken which is passing through or which is passing parallel to principal axis. When they meet again, you will notice they again form an image which is exactly same like the first one, right? Correct? Fine. Madhav, you can if your object is inverted. If your object is inverted, you will get an erect image. But if you are asking me generally, no, we don't. Right? Nice. Alright. Fine. Okay. So, one thing is clear. Whatever special rays you choose, you will get the same image exactly same image, there would be no difference, right? Virtual object, it's something which I won't discuss right now. See, virtual object is something if you take an image inside a mirror as an object, right? The virtual image you take as an object, it's a virtual object, right? So this happens, but right now I won't say. Oblique angle means any angle whose angle of incidence is not zero, I would say. Right? Fine. So, the characteristics are between C and F, okay. The image is diminished and it is real and inverted. Alright? Alright, nice, fine. With this, it's clear. Nice, nice. So, object at C. This is also important. When the object is at center of curvature, now I would not do any special rays. I will just take two special rays, right? Nice, correct. So at center of curvature, what do you see? Object is erect, right? Object is like this, image is like this, but they are of same size. So real and inverted is fine, but it is of same size. So if you notice here, you will see a pattern. When you bring object closer to mirror, image is actually going backwards. Correct? And this is the trick, how you remember these things. When you bring object closer to mirror, what happens to image? Image from small becomes bigger and bigger and starts going farther and farther, right? So my hands are not helping me out here, but you know what? This is what happens. When you bring object closer, the image keeps on going back and back, right? Fine. Yes? So, center of curvature is, what was center of curvature? The center of the sphere of which mirror was a part of, right? Nice, nice, alright. Lateral inversion, I think Kalpesh you were trying to ask. Right now it's not important, but in plane mirrors we used to say, right? Right hand, image is left hand, that's okay. Alright, nice. So this is, image characteristics will be at center of curvature, same size, real inverted. Next, between C and F, what do you see? You brought the object even closer between C and F. Now image went even farther beyond C and it became bigger also, right? Real, inverted and bigger and magnified, correct? Nice. Yeah, Madhav, activity is coming. So once I finish these concave mirror thing, I'm bringing the activity to you. Correct. Now at focus. So just make this pattern. When the object was at infinity, the image was at focus. Now if the object is at focus, image will be at, yes, magnified and enlarged are same. Yes, Jagdeshwar. Yes, Rahan. So real inverted means same. Infinity, Tavishi. Correct. Chetna. Nice. Puvi, Jagdish, Nasira. Very good, very good. Infinity. So you see this pattern, right? This is cyclic pattern. Object was at infinity, image was at focus. Now object is at focus, image is at infinity, right? So this is how you can remember it. So when it is at focus, the image is at infinity. Now you might also think, sir, what I'm seeing here is, this ray is going like this. This ray is also going like this. They both look parallel. How are we saying that they are meeting at infinity? Where do parallel rays meet? Sir, they don't meet. That's true. So what doesn't happen? They are going like this. They are not diverging also. They are not converging also. So that's why what we tend to say is, you know what, where they meet at infinity. That's how we take it. All right. Yes. So this is object at F. Real, inverted, highly magnified and at infinity. All right. Image will be at infinity. Correct. All right. So object between pole and focus. Now this is another special case. See, concave mirrors mein, you will not face any problem till the object comes at focus. Every time it is real, it is inverted, right? That's true. This is same. But when the object is kept between pole and focus, something unnatural, or I would say something special happens. What happens here? So Madhav, I would say there's nothing to prove over here. It's just they travel like this forever, and that's why wherever they find screen, however far, they go like this, and that's why, right? That's why we say it is an infinity. Image is virtual, erect and magnified, right? And magnified. So again, first of all, let me take these two rays and you will believe me. See, I'm taking these two rays again and watch. Guys, right now, why I'm spending time on this? Because ray diagrams is something we all struggle with a lot. So that's why I'm saying, watch very closely. First of all, I have taken the ray which is parallel to principal axis and center of curvature. What do you see? This ray was parallel to principal axis. After reflection, passed through focus, and this ray was passing through center of curvature. So what do you see? Behind the mirror, when you trace them, this is my image. It is inside the mirror. It is erect. It is virtual because the light rays are not actually meeting. You have traced it beyond the mirror, right? Behind the mirror. Correct? Oh, it's okay, Jeevani. Correct? Right? So that's why you have taken two rays. Now, let's take any other two rays. If I take these two now, see, whenever you are trying to make ray diagrams, choose any rays, but make sure you know where the image is going to be, because while drawing ray diagrams, we do these kind of mistakes and we lose marks, right? So that's why. And you have got the circular about how the new exam pattern would be, right? Nice. So let's take these two. One is parallel to principal axis, it will be like this, and second one is going like this. So if you trace them back again, you will see, you will get the image at the same position and the same magnification, correct? Right? Manasvi, you can write both. I mean, any of them. You can write magnified also, you can write enlarged also. Both will be fine, not a problem. Right? Fine? Okay? So I'm hoping after this discussion, you will never make mistakes in image formation. Okay? Nice. So this is the table which I want you to basically create in the end and stick at the wall of your room, because this is important. Fine? Right? So Parvati, just watch this section. See, if I repeat everything again, it will take a lot of time, but I'm saying just watch this video again. But I'm giving you a trick. The trick is object you bring closer, closer, closer. Image goes on backward, backward, backward. But until where? Until the object comes at focus. After that, it is virtual, erect and magnified. Fine. Okay. Nice. You will take print. You can actually. All right. And don't worry guys, we'll give you the notes for this, right? We'll give you the notes in the Telegram group itself. So applications of concave mirror. Now before applications, no, I want to show you something. See, I have brought a candle with me, and what I'm going to show is how the image formation changes. So give me just 1 second. Yes. And I have a concave mirror also, right? This is a concave mirror. So if you watch this candle, what I'm trying to show here is when this candle is near, can you see the image is magnified, right? Can you see the image is magnified? And you know what? You can do this experiment with your spoon also. Same thing will come. You will see that the image is magnified. All right, all right. Is it visible? Okay, yes. Now watch when I take it back. Ah, nice. Watch when I take it back. Can you see the image is inverted? You see that, right? The image is inverted as you took it back. And as I bring it closer, what do you see? This is a virtual image, right? So that's how concave mirror works, right? Fine, nice. And you can do the same activity with a spoon also. And don't worry, I'm going to light this candle because I'm going to use it again. Nice. Wow, good. So always activities enrich the session, right? That's important. Fine. Applications of concave mirror, a dentist mirror, solar furnace and torches. Because you want magnified images, right? That's why dentist mirror, solar furnace and torches. Important, right? So very quickly, let's see for convex mirror. Chetna, you will try it. I'm telling you, you will get it, right? So special rays for convex mirror. If you see, again, same kind of rays. See, parallel to principal axis, and this one it was focused. It was pointed at focus. It became parallel after reflection. Correct? Ah, nice, Jagdeshwar. True. This was pointed towards center of curvature. It will retrace the path back because it is 90 degrees, right? So, all right. Let's have a very quick interactive question now. All right. So, this question will be, let's see. So, move the candle in front of the convex mirror using the slider and observe its image. So, this interactive simulation will give you an idea of how the image formation in convex mirror happens. All right. See, watch. When I move the slider, what do you see? Object is coming closer to the mirror, but what do you see about the image? The image is still diminished, it is virtual, it is erect, right? So in convex mirror, what happens? Image will always be virtual, erect and diminished. That's true, okay? All right. So let's see the question. Based on image formation, which of the following is a similarity between a convex and plane mirror? Plane and convex, tell me. This question, what is the answer? What do you think? Come on, tell me. Virtual image. Plane mirror also have image inside the mirror and convex mirror also have image inside the mirror. No, not real. See, real was where light rays actually meet. In plane also, in convex also, light rays don't meet. They appear to meet inside the mirror. That's why that is virtual, okay? Alright, let's get back. So, object at infinity, what happens? Very quickly I'm going to do this. Object at infinity, what do we have? The image is at focus, highly diminished and virtual and erect. See, it will always be virtual erect. You can just close your eyes and tell this every time. Virtual and erect. When object is anywhere between infinity and pole, it's going to be, what do you know? Virtual, erect and diminished. We know that, right? In that simulation we saw that. Amber, correct. Focus पर बनता है. ठीक है? So, इसमें हमेशा virtual, erect और diminished ही बनेगा. That's true, right? It will always be virtual, erect and diminished. Between pole and focus, diminished, virtual, erect. So this is the table for convex mirror. That is also important, I would say, right? ठीक है? It's just convex mirror में there are less things to remember, but in concave there are more things to remember. So, applications of convex mirror. See, surveillance and safety mirror, rear view mirror and wide view mirror. See, why are we saying wide field of view? This is very small thing I'm going to show you very quickly. If you take a plane mirror, and you take this candle, what do you see? This is going out very quickly, right? It is going out very quickly in the mirror, right? So this is what is happening in plane mirrors. But if I take a concave mirror, watch the difference. It does not go out that quickly. You know, it can travel more area, right? So that's why this is what we mean by wider field of view. Means the convex mirror is able to cover more area. That's important, right? And that's why we use it at surveillance mirror, right? Yes. So with this, I would say this is one homework question. I would just take a screenshot of this very quickly. So people who are here, just take a screenshot. Yeah, Siddharth, I remember you. Yes, it covered more area. It's okay, Madhav, don't worry, we'll discuss about that. Alright. So, this homework question, so I have given you two homework questions. Focus versus principal focus and this one. Alright, so this you all know. And our 45 days plan. By the way, next session will be reflection and refraction, mirror formula and magnification on 1st of June, Wednesday, 6 p.m. Alright, so this is what we'll do. Alright, nice. Telegram channel, guys, please join the Telegram channel. The link is in description because you'll get all these things. Scholarship test you all know. And with this, I would say, like, if you think it was helpful, share and subscribe is because you want to spread the family. That's why. Alright. So with this, I would say let's end our today's session. You take some break. Alright. And meanwhile, I'll also take some break. Let's meet in the next session. And I'm looking for the homework answers. Take care. Bye-bye.